So moving on to the IC, the PWM IC. This is the internal structure of the PWM IC. So we have 16 pins. So you have, let's say, starting from here, this is the input voltage that connects to the input side of the supply. And then you have this so operational amplifier within this integrated circuit. This acts as the subtraction in the control system. This will be the feedback. So this measures this point will be connected to the input of the output of the system, and this measures the the voltage on the output, and then this is your reference. This has to feed the reference voltage. So this will subtract the voltage, and this here it will be the error, the voltage error. This gets fed into this system, and then it decides how much you need to turn it on or off. So this particular PWM regulator IC, you can connect it to two MOSFETs, but then we are only using one MOSFET. So we can, one of these transistors can conduct a certain current. So we will parallel these in the circuit so that you'll have higher current capability. You don't need to use both. So we just connect both the emitter terminals together and the collector terminals together. It will function parallel to each other. So we need to set the voltage reference in this circuit. So this IC, internally it has a voltage reference here that gives you 5 volts, but then we need to decide, we need to scale it such that you can compare it with the output voltage. So let's say if you are directly feeding in here 3.3, so then you need to scale this voltage with a voltage division resistor network to give you 3.3. So then you'll be measuring 3.3 and then comparing it with the actual voltage. You'll be setting the reference at 3.3, comparing it with the actual voltage, and if that changes, this will change the switching. So this switching has a certain frequency. So in this, that's determined by this oscillator part of the circuit. The CT and RT determines what the switching frequency is. You can connect a capacitor and a resistor combination here, and that will determine the frequency of the oscillation. And you can also measure the oscillation here. So that's just for measurement. We don't use it for anything else. In addition to that, you also have this current sense terminals. So if this voltage potential between these 2 points increase above a certain voltage, I think it's 200 millivolts, this IC will try to shut down the switching. So that means if you have a high current, you can detect the high current, and that across the voltage across the resistor, the sense resistor goes above a certain voltage. The PWM regulator chip will try to shut down the MOSFET. So that's the function of this. This is for protection. This is the control part of the circuit. So I'll just go into the data sheet as well. That's LM3524. So before you work on it, go through the data sheet as well. So each of those pins can source up to 200 milliamperes. So that's the this one here. This one of these transistor components that's within the integrated circuit can source up to 200 milliamperes. If you parallel them up, you can source 400 milliamperes. So this is the pin arrangement, and you have all the pins here. The compensation pin, that's somewhere here. This is pin 9. The compensation, you can connect a RC network into the compensation, and then that will act as the PI controller. So you can connect a capacitor. If you connect a capacitor, then it will be like an integral action. You can test it out. If you just connect a capacitor, you'll see the voltage rise is really slow. If you connect a resistor together with the capacitor, you'll add a proportional gain as well. So then you can test it out with different capacitors and resistor combinations to see how the response changes. So you have these specifications. This is the input supply voltage. So the supply voltage can go up to 40 volts. So it can be anywhere between 7 to 40 volts for the circuit to function properly. And this is like a rough maximum frequency of 500. So we are going to design it for 100 kilohertz. You can go up to 500 kilohertz, but then the inductor is sized, it's given to you so that it works for 100 kilohertz. So the frequency is determined by this particular function here. It should be given somewhere here. So here, this is the relationship between the oscillator frequency and RT and CT. RT and CT are the resistors connected to the RT pin and the CT pin. You can choose these two values so that you get 100 kilohertz here. It won't be very accurate. If you can, you'll find if you decide RT and CT and then connect it and see, you might not get 100 kilohertz. You might get somewhere 90 kilohertz or something like that. This is approximate equation.